So, very good evening, everyone. Today is day 5, and as per the agenda, I am going to discuss the probability distribution. In the few last 4 sessions, what we have seen the basics of R. I tried to explain you that how we can create variable in R. Then we have seen the various kind of data structures in R. After that, yesterday we tried to discuss about the functions, that how you can use the inbuilt functions, and then we have also seen that how we can define or how we can create our own functions in our environment. This is what we have seen till the day. Today I'm going to discuss probability distribution. I'll try to cover today binomial, Poisson, and the normal distribution using R, right?
Right, ma'am.
Yeah. So give me a second. I'm going to share my screen.
Chanchala ma'am, you gave a problem yesterday
Yes.
regarding this digits, some of the digits of a number.
Okay.
So I've done it. I've found a way, I've found
Okay.
some way.
It's
So maybe,
great.
yeah.
So can you share the solution with the remaining participants?
I can share. May I share my screen first?
Yeah,
or,
no problem. You share first, then I'll share.
Okay, I'm going to share my screen.
Yeah.
Is my screen visible?
No, I think I cannot see.
There's some
Anyone
infinity
who
error.
can see?
Just wait, ma'am.
Yeah.
Let me just try again.
Okay.
Oh. I'll share the. Okay. Is it visible now?
I think we can see now, but yeah, now we can see.
The text size is okay.
Yeah.
Okay. Here's the function, ma'am. I'll just open it a bit.
Okay.
Better now?
Yeah, it's better now.
Okay, I've taken the name of the function as sum. Okay. And I'm passing one argument to it.
Yes.
Now this double percentage is used to extract the last digit of the number. Okay?
Remainder.
The remainder, yes.
Yeah.
And once I've taken the remainder here in R, okay, what I can do is I can remove that last digit from the number. That is done with this percentage slash percentage.
Yes.
This removes the last digit.
Yes.
Okay, and then I can repeat this process till the number is greater than 0. So ultimately, while I remove the digits, the number will become 0 and this while loop will end. And then I've called this function with this. So I'll just run it here. You can see the sum of the digits is 27. If I run it with say 1, 2, 3,
Yes.
accordingly it will see this.
Yes, very correct. Yes. So, sir, you can copy and paste your solution.
I'll paste it.
Check,
Yes,
yes,
I'll
so that
paste it.
everyone can use it and can understand
Right.
the steps, right?
There are two simple things. One is to get the remainder with this percentage, and to remove the last digit of the number, it is percentage slash percentage. That's it.
Yes. Fine.
Okay. I'll stop the share now, ma'am. You can continue, please.
Yeah. Thank you.
Okay, ma'am.
Excuse me, madam. I have downloaded the Art Studio, but I am not getting the left lower quadrant. That is the console. I am not getting. Why this problem is there?
Is it possible for you to share your screen, Geeta ma'am?
I am just opening, ma'am. Meanwhile, I am doing. Then in between, I will do.
So can you share? Is it possible for you to share the screen?
I am trying. Just I am doing on phone. It takes time. Madam, you start, please.
Okay.
Meanwhile, we will do.
Okay,
I will
definitely.
share.
Okay, definitely. Thank you.
Chanchala ma'am, I've shared the solution in the chat.
Okay, okay. Fine, sir. I think everyone who wants to see the solution of the problem we have seen or I have given yesterday, you can see in a chat, sir has written everything, right? Ajay sir has written everything. It is good. You can see and check. And you can also run the same, right? I am sharing my screen. Give me a second. Yes. Okay. So I think my screen is visible.
Yes, ma'am.
Yes, ma'am.
Yes. So today I am going to discuss probability distribution. As we know, probability meaning is that we want to, or we can say it is a chance of occurring any particular event, right? So that is the probability. Now when I talk about probability distribution, so probability distribution means it's a distribution of the probabilities of the probability of any particular event, right? So that means distribution of probability of the outcome of any event is known as the probability distribution. So I can write here distribution of probabilities of outcome of any event is known as probability distribution, right? So usually when we talk about the statistical analysis, it is very imperative to know the distribution of the data, that how your data is behaving. So using the probability distribution, we can understand the distribution of the data. And in this context, if I talk about the mainly used probability distributions are, generally we can say it's a discrete and continuous. These are the two distributions generally we are talking about in statistics. But apart from that, there are some other distributions also available, right? Chi-square distribution is also there. T distribution is also there. Uniform distribution. So that way, there are a series of distributions available in statistics. But mainly three I'll talk about today under the discrete and continuous. The first one is binomial, then Poisson,
Alright.
then
Normal.
normal distribution, right? So talking about binomial is what? It is a kind of discrete. Discrete meaning is whenever I talk about the binomial distribution, the outcome would be, or the nature of the outcome would be discrete, right? Say for example, if I'm saying I'm tossing a coin, so once I'll toss a coin, so the outcome will be either head or tail, right? So that way, the outcome would be a complete number. That is a discrete number, right? So that way we can call that binomial distribution is a kind of discrete probability distribution. Here, there is, we are assuming that there will be only two outcomes. And these two outcomes are generally known as the success and failure, right? So we need to have the probability of success and probability of failure with us in the binomial distribution. Generally, if I talk about here, the probability value will not be very less. The probability should not be very small, right? This is known as the binomial distribution in the statistics. Talking about the Poisson, so Poisson or Poisson distribution is again a kind of discrete probability distribution, because again when I talk about the nature of the outcome which we are using in the Poisson distribution, so that would be the discrete in nature. Say for example, if I'm saying how many calls I am receiving on my mobile phone in last 1 hour, so that would be the number of calls received by me in particular period, right? So that way it is a kind of Poisson distribution. Again, if I say Poisson, binomial and Poisson, they are very similar, but the problem is when I talk about Poisson is generally based on the time. In means there would be a time intervention when I talk about the Poisson distribution. The way I said, in the last 1 hour, how many cars have been passed on this particular road, right? So that way it's a kind of time limit would be there. In that time limit, I'm trying to understand the outcome of that particular event, right? So this is a discrete probability distribution. Here, if I say generally the n, that is this size of the sample, right? It should be sufficiently large. And the probability value will be very small in comparison to the binomial distribution. And here the time intervention is also an important thing. Here there will be the time bound events, right? So that way we can make a difference in binomial and Poisson distribution. Talking about the normal distribution, it is a continuous distribution. Continuous means here the nature of the variable will be the continuous in nature. Say for example, if I'm saying in my class, if I'm measuring the weight of the students, so how many of the students weight is more than 60 kg, or how many of the students weight is less than 50 kg. So I know less than 50 kg means it can be 49.9 as well, or it can be 48.2 as well. So that way the variable nature or the outcome of this particular variable or distribution will be continuous in nature, right? So this way, this is known as the normal distribution. Now, if I talk about firstly binomial, right? So for getting the binomial distribution manually, the probability if we want to get the binomial distribution, usually manually we know the formula is NCR p to the power r q to the power minus n q to the power n minus r. I think maybe you have seen this particular probability formula in the statistical books, or maybe in your courses or somewhere you have studied this, right? If not, so I think I will not go in the manual probability distribution calculations. We will see using the R that how you can calculate that, right? So here there are 4 functions we are using. The first one is the binom. So in binom, you need to pass the x, you need to pass the size, you need to pass the probability, and then here there will be lower dot tail is equals to 2, right? Now, I think I'll explain the meaning of this one by one, right? Second would be the p binom. Again, the syntax is similar here. So I'm copying this and pasting it inside this parenthesis. Now, talking about here, if I talk about the next, it should be the Q binom, quantile binom, right? So here we will be having P, we'll be having the size, we will be having the probability, right? And then you can put here lower dot tail equals 2. And the last one is the R. R binom is the random. This will generate the random numbers which are following the binomial distribution, right? So here you can write N, you can write size, you can write the probability. So these are the 4 different functions available to get the probabilities in the binomial distribution. If I talk about the first function, which is the binom is giving you the probability value of exact outcome. So when you want to get the probability of exact outcome, you need to use this function, right? But when you want to get the probability, cumulative probability, cumulative meaning sometimes it is written like less than or more than, something like this. In that case, you will use this p binom function. Q binom will be used when you are having the probability and you want to get the value of x. Find the value of when probability is given. This is known as the binom. And lastly, and lastly, the R binom is what? R binom will help you to generate R or N random numbers which follow binomial distribution. So this way, these are the meanings of these 4 different types of functions in binomial distribution. I hope you people have written. If not, I'm copying this and pasting in the chat. Just a minute. So you can copy from there. Okay, I have shared there on what's chat. If you have not written what I was telling, you can copy and paste in your R script or somewhere in your notes or wherever you want, right? Done? So now I'll take a problem to understand when you need to which function and then how we can do the plotting, etc. to understand the binomial distribution, right? So I think I have written questions on a Word file. Give me a second. I'm going to copy all the questions one by one. Give me a second. This will save our time. So for the purpose, yes. So do I need to copy the question on chat?
Yes, ma'am.
Okay, just a minute. I think it should be more readable. So I'm making it readable on the chat. Find the probability of getting 5x when a coin is tossed 10 times. Yes, I have shared the question in a chat. I hope you have found the question.
Yes, ma'am.
Yes. Now, I think so many tabs are open. Yes. So I am here again on a R script screen. Now you can see it's the same question I have taken here. You can read the question. Question says, I think I'm reducing its size. Yeah. Question says to us, find the probability of getting exactly 5 heads when a coin is tossed 10 times. So here you can see, after reading a problem, we can easily understand we need to get the probability of the exact outcome. And the exact outcome is 5 times heads we need, right? So we need to clearly, it is understandable, we will use the first function, right? I hope you can relate.
Yes, ma'am.
Yeah. So now I am coming here and I'm writing the binom. Inside that, you can see it is asking me to provide the x. X will be the outcomes, that is the 5 outcomes we need, right? Then you need to pass the size. So size means how many times you are performing that experiment. So we are performing the experiment 10
10
times,
times.
right? So now you need to pass, next is the probability. So probability of getting a head will be the success for us. And we know when we are tossing a coin, so there will be only 2 outcomes. First is head, second is tail. So probability will be 1 by 2 and 1 by 2, right? So either I can write 1 by 2 or you can write 0.5, right?
Right.
By default, lower dot tail will be true, although in case of this particular function, there is no need of this. So I think without this also you are writing or saving the particular function, that would be, I think, much better, right? So I have removed that because we are looking for the exact event. So there is no use of lower tail or upper tail, right? So that is why I have written this. And these are the 3 necessary or compulsory parameters you need to pass in the inside the parenthesis that I did, right?
Chanchala ma'am,
Yes, sir.
Chanchala ma'am, when I write this that you're telling lower dot tail, it gives an error.
It will give. That is why I have removed, because we are looking for an exact probability, sir. When you are
Right.
looking
And
for
ma'am, what is the meaning of this lower dot tail?
that I'll explain you in the next
Okay.
question, sir. Then
Right,
when we
right,
will
right.
do the remaining functions.
Right, right.
Yes. Now I think this is sufficient for us. You can press Control Enter to execute this, and this will give me the probability value as 0.24. Or if you want to round off this, so you can come and you can use the round functions. Before this, okay. So it is returning me 0.25, right? Up to you, the way you want the output, right?
Ma'am, please explain why after 1 by 2 again 2 is written.
Okay, I'm making it easier for you, sir. What I did, as you can see previously, the probability values was coming as 0.2460938. It is a very long or the big figure, right? So what I did, I have rounded off this particular value up to the 2 decimal point. So I have used, before this particular function, I have used one more function with the name round. And in the round function bracket, I have passed first parameter is this particular d binom function, and then after the comma up to the what decimal point you want to round off the answer. So that is up to the 2 decimal points. When you have done this and you have control enter, you press, you get this answer, that is 0.25. I hope it is clear, Santosh sir.
Yes, ma'am. Yes, ma'am.
Yes. So we got that the probability of getting exactly 5 heads will be the 0.25 or 25%. Fine. May I
Yes,
take
ma'am.
this problem? Okay. Give me a second. I'm copying and pasting to save our time, because today we are having a limited time. We need to complete so many things today. And I'm coming in a chat. I think I have pasted it. In a chat. I hope you got.
Yes, ma'am.
Just a minute. This is the second problem I have taken, right? So here I'm writing solution. It is easier for us to understand, right? Now this is the question number 2. Question is, a coin tossed 4 times. What is the probability of getting no head, right? So first thing, I will find the first thing, this one. So suppose I am finding the solution for no head, right? So here I am writing what is given to me. X will be
0.
0. Very good. N will be
4.
very good. And then probability will be
1
0.5.
by 2.
1 by 2 or 0.5, one in the same thing. Both way I have shown you. This way also you can write, this way also we can write, right? Now, as you can see, first thing is we want to find the no head. No head means it's an exact outcome, right?
D binom.
Yes, so we will use d binom. Inside this, I am writing 0, 4, 0.5. Pressing Control Enter. Answer is coming here 0.0625, right? Fine.
Yes, ma'am.
Now we will move for the second. Solution for at least 2 heads. At least meaning is minimum 2. Maximum
Four.
can be up to 4 as well, because we are tossing a coin 4 times,
Yeah.
right? So that means we are looking for X should be greater than
4. No, 2.
2.
and equals to 2, right?
4.
Right?
Yes, ma'am.
So now Sorry, I hope no doubt, right?
Yeah, it will fall into what, Q binum?
No, it will fall in the P binum.
P binum. Okay. Yes, P
See,
binum.
I'm
Right.
making it little more easier for everyone. So this
Yes, ma'am.
also I can write, right? X should
Right.
be 2, 3, and 4. Fine.
Yes, ma'am.
Now coming to the function and using P binum, as I told you already, P binum we are using for what purpose? P binum we are using for getting the cumulative probability. Here we have written this, right? So it is quite obvious. We want to get the probability of 2, 3, and 4, right?
Chanchala ma'am, 1 second. Why the name P binum? Does it correlate to Poisson?
No, P stands for only probability of PDF function.
Okay, and
P is
Q?
only for the probability, sir, usually if I say.
And Q?
Q is quantile. R is random.
Random. All right. Fine.
So coming here, at the first position, you need to pass the value of the X. Here I am writing 1. I'll let you know why I have written 1. Then I am writing the 4. I am writing the 0.5, right? So here you can see when I have told you these functions, P binum, here the lower dot tail is true. Ajay sir, now you I think understand this point. Lower
Yes.
dot tail meaning is, I said lower dot tail is true. Meaning is whatever the first position value I am passing, it will be
Yes.
it will give me the probability of less than or equals to 1.
Okay.
So less than or equals to 1 meaning is 0 and 1,
Okay.
right? Now I want to get the probability of 2, 3, and 4. I want to go to the upper side, right? So I need to pass the next parameter as false. By default, it is true. So it will give me the probability of 0 and 1 if I will execute without passing the F. Once I have
And
written,
if you make it true, it will go to the other part.
yes, if yes.
Okay.
When I have written is F, that means it will give me go to the upper side of 1. That is 2, 3, and 4. Fine. May I press Control Enter?
Yes, ma'am.
So the answer is 0.6875. 68.75% chances are there that once you're tossing a coin 4 times, so at least 2 times heads will come, right?
This second one is not clear. Line number 447.
Okay, again I repeat.
Yeah.
I said binum function is requiring Q size probability and lower dot tail is equals to true, right? So Q we have given here 1, right? You can see I have given Q value as 1, right? I'll explain you again, sir, why I passed here 1. Then I think N is clear to us. N is 4 and P is 0.5, right? So lower dot tail is very important to understand here, the fourth parameter, right? Lower dot tail will give you what lower dot tail means. It will keep you whatever the first position value you are passing. First position I have passed here 1. So that means if I have written here 1 in place of Q, it will give me the probability of 1 and lower than 1. So if I'm tossing a coin 4 times, so it is quite possible. Maybe the coin can be turned up 0 times as a head, 1 time, 2 times, 3 times, or all 4 times I can get a head. Is it quite possible, right, sir? Santosh sir, understanding?
Yes, ma'am.
So lower dot tail is true, meaning is that if I have written here 1, this particular function will return me the probability of less than or equals to 1, right? But here I want the probability of greater than 1, right? So that is why I have made this particular parameter as false. So once you are making it false, it will return you the probability of upper side of 1. I hope I'm making sense. Are you
Yes,
getting
ma'am.
it?
Yes, ma'am.
Yeah. Chanchala, that means like the line 447 that you've written, it means that we are looking for a probability of, if it would have been true, it would have been 0 and 1, the first
Yeah.
argument.
Yes,
And if it is true, it will go on the other side, 1, 2, 3, 4.
no, if it is
Oh,
false, yeah.
If
If it is false,
it is
very
false, then
important.
one is included or not?
1 is not included.
Okay, fine.
Yes. Now, one more way is there to find this. You can do this also.
Yeah, 3 and then 4.
Yeah. It is invalid, you can press enter and you can one by one add them, or individually you can calculate and you can add them. This is also possible, right?
Yes, ma'am.
Although I think it is giving you answer, you can see here with the warning. I have highlighted it. You can see, right? It is returning you the answer. Same answer we are getting. Fine. Santosh sir, if you are
Yes.
unable, you are not much clear about this particular p binom function, this way also we can get the solution,
Okay, ma'am.
right? So I think
Yeah.
I am writing here or, right?
Okay.
Now going for the next.
Chanchala ma'am, I have also run it, but no error. Maybe the version issue.
No, I am not getting any error, sir. It is only giving me a warning.
Yeah, that's what I'm saying. No warning, just a clear-cut answer
Might
on
be
my
possible you are
alphabet.
using
Yeah.
maybe latest version, because my version is little older.
All right.
Yeah. Okay, so now we'll go for the next. So now we will get the solution for exactly one head. Can anyone attempt how I can solve it?
B binom,
Sorry? Sorry?
B binom,
B or P or D? What you say, ma'am? I'm not clear. So,
B.
ma'am?
I said B ma'am.
D binom. Yes, very correct. Very correct. It's D binom. Then at a first position, I need to pass 1,
1.
4, 0.5. Very correct. Then
Yes ma'am.
now next is this last. Now, which function I need to use?
P binom.
P binom, right? So here I am looking for more than 2 heads. That means I am looking for x is greater than 2.
2,
Or I can say x should be equals to
3,
3.
4.
3 and 4.
So here what I need to write?
P binom.
Yes, then at a first position what I'll pass?
1,
You should pass 2.
2, okay. Then
Yeah.
4,
Then the 4, then 0.5.
0.5. True.
Then
Then I
Lower
think it
tail
should be
true.
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 it should be true.
On
Yes.
that side. It should be true, I
Yes
think.
ma'am. True ma'am.
True.
So,
More than 2 heads. Yes ma'am.
Fine.
Yeah.
May I execute this?
Why ma'am? True. Lower tail you should not put ma'am.
So I need to use what?
2,
Lower tail true.
0.5.
By
Answer
default, it
then
is true,
T.
ma'am. If you
No,
are writing,
yeah, okay.
it is by default true.
True.
okay.
Okay ma'am.
So we can miss the 4th argument, no problem.
Yeah, it is not mandatory. If you are not
Okay.
passing, it will take by default true.
All right.
So,
If we
okay,
need to
okay.
pass false, then we need to write.
Then you need to
Right.
write.
Yeah.
Okay.
So is it okay? Fine.
Yes ma'am.
Yeah, but we need some practice, I suppose, because a bit confusing to begin with.
You can see answer is not correct.
Okay.
We need to write. Okay.
Right?
Yeah, that's
Why
the
false now?
confusion actually. Can you just explain this, like how
As I
this
said,
is not clear?
greater than 2, sir. Only logic you need to understand. Greater than 2 meaning is if I'm keeping 2 here and I'm making it true, so it will go to the lower side, 0, 1 and 2.
Okay.
And I want to looking for
Okay.
3 and 4.
I need to put it.
Okay.
Okay. So if we
Alright.
need to, okay, fine.
Understood.
Clear?
Yes, ma'am.
I need to find if I am having one more question, I'll take. Yeah. We are having one more question. I think I need to copy the question there in the chat also, right? Give me a second. I have copied down a question in chat box. Done. Question says, a dice is thrown 5 times. If getting an odd number is a success, find the probability of getting at least 4 successes. So here I can say X will be right
4.
greater than or equals to 4, at least minimum 4, right? N will
Right.
be 5 and P will be
3/6.
1/6.
Odd number can come in.
Because in a dice there are 6 phases. 6 phases.
Yeah.
So we
Okay.
are getting only, we are looking for a one phase only, right?
Okay. We are not looking for that odd part, right? Okay.
No.
Right.
Because we are saying getting an odd number is a success, right? Okay. Yeah, you are correct, sir. It will be 3/6. Sorry. I made a mistake. So it will
Yeah,
be
because 1,
Yeah.
3, or 3
Yeah.
outcomes, so out of 6, so it should be.
all this. Right? Now, how we can find this? Which function I need to use?
P. P binom.
It's P binom. Okay. Okay, then what I need to pass as a first parameter?
Oh, greater than or equal to 4. So 5 maybe? No, 4, I think.
4.
I think so. That's some confusion about it. Okay, you go ahead, ma'am.
4,
Okay.
6.
4,5, 0.5. Right.
Okay, then anything else or may I press enter?
You should write false here.
False. Okay. Is it okay? Everyone?
Seems okay. You will tell.
I think according to me it should be 3, not 4.
Okay.
Because
Okay, it does not count here. Yeah.
including 4 we are including at the upper side,
Yes.
right?
Right.
So it should be 3.
Right, ma'am.
Answer will be 0.1875, right?
Yes, ma'am.
Fine. I think one more problem I'm having, but I think I'll that copy and I'm just copying and pasting this problem there in a chat that you please practice by your own. I'm not taking this problem because now I'll move for the next, right?
Okay.
For you, I'm sending the question. Give me a second. I think I made a mistake. Yes. Okay, fine. So you copy paste this question and please solve later on, right? So I'll go for the next thing now. I'll take the next. Okay, I need to switch. Yeah. Now I'll come to the next function. I'll talk about the random number generation, right? Suppose we want to generate 10 numbers which are following the binomial distribution with the probability, suppose 0.5. So I'm writing a problem here. Generate 10 random numbers. Generate 10 random numbers from the sample size 50 with 0.3 probability Give me a second. I'm copying and pasting this in a chat, right? I hope you got it.
Yes, ma'am.
Right. Now coming in a R, yes. Right. So now we know to generate random numbers, we need to use R binum, right? So I'm writing R binum. I want to generate total 10 random numbers from the sample size of 50
50.
and with the probability 0.3. Right? You can get. These are the 10 random numbers which are following the binomial distribution, and the probability of generating them is 0.3. Right? Clear?
Yes, ma'am. Yes.
Okay. Just a minute. What I'm doing. So this way we have generated these numbers. Now, if suppose I'm storing these results here in X, right? Done? Now, using the T binum, suppose I am writing the X, comma 10, comma 0.3, right? Now, using a plot, I'm plotting Y. I'm making this down.
It should, yeah, X comma Y. That is better.
But it is not generating a histogram. That is what I'm looking for.
Yeah, in suggestions it is
Well,
Y.
whether screen is visible or not. My screen is visible, sir.
No,
No, ma'am. No, not
that's
now.
what- previously it was visible.
Yeah,
Yes.
it was visible,
Okay.
but the plot was not there.
Yeah, plot was not there, but the problem is I thought my screen is not visible to you people. Just a minute. So coming down, where it is.
Chandala ma'am, I've used the H value. Maybe it's the margins issue. It's saying it's 2. So use some value is 0.25, I suppose. It gives some plots, scattered points.
It is giving you.
Yeah, it is giving scattered points to me. I've written H is equal to 0.25. Use H. Maybe that's some step size. I don't know. You can tell.
Histogram, it is creating a histogram for you, sir.
I don't know. I've written X comma Y comma H is equal to 0.25. Without quotes, you write H is equal to 0.25. Maybe. I don't know the meaning actually. I just tried using the, yeah. This way, yeah, I'm getting scattered points like this.
But I have passed H as a histogram. I want to create a histogram.
Okay, I don't know. Just tried, so not very sure. Yeah.
Just a minute, just a minute. I'm doing one more thing. I am creating, suppose, one sequence. 0 to 20, suppose, right? What it is giving me? Now, suppose I'm writing D binom and passing X of 20, and suppose probability is 0.5, right? Now I'm plotting it X comma PDF and suppose H. It is working, right? Now you can see, suppose I have taken a sequence 0 to 20, means 0 to 20 numbers, 0, 1, 2, 3, 4 up to 10, sorry, up to 20 will be stored in the X. Then for this X, I have passed, or I have used this D binom. So that way the value of X will be 0, 1, 2, 3, 4, 5, 6, 7, 8 up to 20, right? Because this is the 20 size. And then I'm plotting a plot or a graph using the
X versus PDF.
and Y, right? That is the PDF, that is the exact probability distribution, I can say, right? And then I want to plot a histogram. So I passed here H. So this way you can see, this is a histogram.
And what is PDF?
PDF is name of the variable, sir. You can use here Y also, no problem.
Oh, okay.
Right? So that is also work. It is not necessary you need to pass PDF. You can write Y also. Fine?
Yes, ma'am. I think in the previously when you wrote, I think it was going beyond the boundaries of the this thing.
Might be
plot.
possible. Might be possible because the numbers, random numbers were the out of 50, the random numbers will be generated, 10 random numbers. So might be possible there can be a problem of these margins.
Okay.
Fine. So
Yes,
this way, this is known as the binomial distribution, talking about the distribution.
Chanchala ma'am, what about some other plots with that for this?
L also you can use. I think L is for line.
Okay. Can we use a pie? Can we use a pie? Okay.
Even numbers is also defined, sir. 1, 2, 3 also you can check.
Okay.
One is probably for the bar plot, something like that. So even numbers are also there in our. Using the number also we can plot the graphs.
Okay.
Suppose I have written 1, so it will generate the suppose bar plot. For 2, the 2 is dedicated for some other graph, something like that. So inside a graphical functions, if you are passing these numbers, so R understands in the environment of R, it is clearly defined. So that way it will take that or it will draw that graph for you.
Okay, and how many arguments this plot function can take?
There
You've
can be
written
some
3.
more. If you want to change in the colors, if you want to change
Okay.
in the axis, so we have you want to name your this particular
Axis,
graph. Graph also title you want to provide, so title also you can pass here. So that
all
way
this is given as arguments of this plot function you were saying, right?
Yes.
Okay. Fine.
I'll try. If in any of the session I can give you some more about this particular, I'll try to do, or if not, so I'll provide something in a chat. You can copy and you can try by your own.
All right.
Yes. So now coming to the person, so I'm saving my time. I have copied down the functions. So I'm taking these from here. I'm copying in a chat also for you. So again, here in the Poisson distribution, we are having D, P, Q, and R, meaning are same. But here in the case of Poisson distribution, you do not need to pass 3 parameters. Here only the 2 parameters are sufficient, X and lambda. Log also we are not using. You can cross this, right? Only this is sufficient for us. Now lambda is what? Lambda is the mean value of the Poisson distribution, right? Now talking about the first problem. I am putting a problem there in a chat. You can read the problem. If there are 12 cars crossing a bridge per minute on an average, find the probability of having 17 or more cars crossing the bridge in a particular minute. So, what will be x, or firstly, which function we need to use? Meanings are same. When you need to use d binom, d poise, or maybe the p poise, q poise, something. So the meanings are same. Which function we will use here?
D poise, ma'am, D poise.
P poise. Very correct. Santosh sir, very correct.
Yeah.
Good. So if I talk about x, what will be the x here?
Maybe 12. I don't know.
12.
Not sure, ma'am.
Okay, fine. So x will be greater than or equal to 17. We want to find the probability of having 17 or more cars crossing the bridge, right?
Okay.
And then talking about lambda or mean. Mean is what? On an average, 12 cars passing, right? So we can write mean is 12 or lambda is 12, right?
Okay.
Coming down using the PP OIS, P poise, right? Inside this, what I need to pass?
For 17, comma,
Okay.
well, 16, comma, 12. Okay.
Is it okay?
Yeah.
Fine.
17 or more.
Yes, 17 will be included at the upper side. So we will take here 16.
It will go towards 17, 18, 19. Yeah.
I think it will be more. 17 or more.
Yes. So I need to write here, according to Gita ma'am, I need to write here what?
Means ma'am 18.
Why 18?
17
I think
or more.
understand.
17?
I think we. Yes. Please complete.
17 may be written. 17 or more. 17 it is included.
Because I haven't included, and I think I have just discussed the concept when I was talking about the binomial. We are going for the upper side, but 17 is included at the upper side. 17 or more. It is
And
not
whatever we mention as the first argument here, it is not included if we go towards the upper side. Yeah.
It will be included at the lower side. When you are keeping it true, it will give you up to that
Yes.
from the lower side.
From 0 to whatever.
0 to up to that number.
Yeah.
Geeta ma'am, I hope you are getting me.
Yes, as it is false, then it will be below 17. Is it that
It
right?
will be above 16.
Yeah, 16 won't be included, and above 16 it will start.
It is
17
above 16. You can write here it is above 16. That is 17 or more. Right?
Okay.
Now it is clear, ma'am?
Yes. Yes,
Okay.
ma'am.
Yes. Now, I think I am not going much deep into the Poisson because Poisson is not that much useful for us. But if I'll having some more problems available to me, I'll post to that you people, right? So that you can practice. Now, talking about the most important distribution, normal distribution. I don't know how many of you are good in statistics, or maybe I think you people have studied normal distribution, and we are knowing this thing that when we talk about the various statistical tests, we need to check whether the variable is normally distributed or not, right? So we need to know firstly what is the characteristics of normal distribution. Generally, if I talk about standard, I'm using a word standard here, please pay attention. It is standard normal distribution characteristics I'm talking about, right? So what are the characteristics of the standard normal distribution curve or the data? So this type of data will have mean as 0 and standard deviation as 1, right? Skewness will be 0 and kurtosis should be
No kurtosis.
0, right?
Yes. Yes.
Then the area, generally it is depicted by bell-shaped curve, right? And the area under the curve will be 1, right? So these are, apart from that, there is one more I need to write. Mean should be equals to median, and it should be equals to mode, right? And center of the curve will be the mean value. Usually these are the few of the basic characteristics of the standard normal distribution curve, right? Now, if I talk about, I need to check whether I have copied down the functions. Yes, it will save our time. So these are the, do I need to copy the functions in a chat, right? To save your time also, so that you people can also copy and paste in your notes. So I have copied down, these are the 4 functions we are using in R to get the probabilities of the normal variate, right? So if we talk about the denorm will give you the probability of the X and it is exact outcome. Bnorm will give you the probability of X when this X will be the cumulative type of outcome, right? Qnorm will give you the probability of finding the means probability of getting the X, means this will be the reverse of your denorm, right? R norm will give you the probability of the random numbers, or sorry, R norm will generate for us the random numbers, and random numbers which will be having this particular mean and this particular standard deviation. So this is the normal.
Ma'am, I think we need to, we'll correct it. Whatever you shared last 2, the spellings are a bit jumbled. Instead of
From
norm,
this,
it is n norm.
Denorm will give you the probability of the exact outcome.
Yeah.
Tnorm will give you the probability of the cumulative outcome. Qnorm will give you will give you the value of the X when you are knowing the probability. Means it is opposite of your denorm. R norm will help you to generate the n random numbers which are following the normal distribution, which will be having a particular mean and standard deviation. Is it fine, sir? Do I need to repeat?
No, I just wanted to say that the last 2 functions are spelled
Yeah.
incorrectly.
Last
N norm, yeah, Q norm is QN and QN ROM.
Norm. R and O are interchanged.
Okay.
Yeah, we'll
Okay.
correct it, but yeah.
Sorry, it is a right. It is a typographical mistake from my side. Thank you. I think I have changed, right? Now it
Yeah.
is fine.
Yes, ma'am.
Okay, I'm coming in a chat and again copy and pasting it. Please, if you have copied it previously, delete, and then whatever I copied just now, please copy and paste that in your notes. Fine. I
Yes,
need to come back to this and I'll take a question from here. Question, I think I need to copy in chat also. Give me a second. I think question is there in a chat.
Yes.
Yes. Coming here, talking about x is a normally distributed variable with mean 30 and standard deviation 4. We need to find the probability of x when x is less than 40. So which function I need to use?
Maybe D now. We have an exact number.
Okay.
No, x less than 40, or maybe it's cumulative. No idea, ma'am.
P norm, sir. It is not exact. It is less than 40. So
Yeah, it is cumulative. Yeah.
less than
Yes.
means it can be any number,
Yeah, any number. Right.
right? So we will go for
Cumulative.
P norm.
Yeah.
And that way we need to pass the value of Q will be what? What I need to take? 40 or 39 or 41?
Do we have something like a true or false here also as the fourth argument?
Yes, same.
Okay, fine. So we need
Maybe
less
39.
than
39, okay. Then mean is 30. Standard
39 and then true. Yeah, 40 and true, I suppose.
40
Yeah,
and 2.
39. Yeah, 39 and true maybe.
This
Just a second.
39, 34, then false, I guess.
false.
No, false will go towards the other side, so it should be true. And 39 would be included, I suppose. So yeah, I think up to 39 it would be something like this.
This is correct.
Yeah, seems good.
It's correct. This will be the answer. By default, it is true. So I have not passed T. If you will pass, even then your answer will be same.
Yeah.
Right? Done?
Yes, ma'am.
Now talking about the second finding. That is Px, probability of x when it is greater than 21. So this would be
This would be P norm 21, 30, 4, false.
okay.
I think it should be the.
Okay, so P binum, I need to pass here what? 21?
Yeah, 21. If we go towards false, won't be included. So 22 onwards. Yeah.
21 is fine.
I think it's fine, ma'am. You will tell 21, 30, 4, F.
Okay. According to me, this is correct.
Yeah.
May I press Control Enter?
Yeah, it gives the same answer. Is that fine?
No problem. Because
Okay.
we are, because we are talking about, I think, 40.
The middle, yeah.
It is almost half. So
Yeah.
probability will be almost similar.
Okay.
Right? Now, talking about the next. You need to find the probability of x when it is lying between 35 and 30.
One way is we can use D norm with 31, 32, 33, 34. One way is by adding that.
Okay.
I'm suggesting, I don't know if it's correct or not.
Okay. No issues. Anyone else? We can fragment our this particular thing like this. Firstly, we can find the probability of
31.
x when it is greater than 30, right?
Yeah.
This is the one thing we can do. And also, we can find the probability of x. Where it is, yes, when probability of x when it is less than 35, right?
And what do we do with these two values?
We'll subtract.
Okay. Subtract from that 35, we'll subtract the 31. Yeah.
Yes, right?
That's
So,
good.
yes. So suppose I'm talking about probability of p when x is greater than 30. So what we will do here, we will use p by p norm, right? Now at the first position, what I need to pass?
You can pass 31.
31.
And then 30 and then 4 and then on the other side it goes greater than. ये थोड़ा confusing.
Yes.
Should be false, I suppose, but yeah.
Fine.
Yes, ma'am.
I think this is fine.
Greater than 30.
Maybe
Yeah,
29, madam.
Sorry?
29.
Why 29, ma'am? Logic is x should be greater than 30. So if I'm putting here 30, so it will, and I'm keeping it false. So that means it will include the probability of greater than 30. 30 and above. So
Okay,
above
okay.
30,
It is not
right?
equal to 30 or greater than 30. That's why it maybe started from 30.
Right?
Yeah, right.
Now P norm. Just a minute. I think we need to write probability of x less than 35. Right? So P norm. Now
34.
34. Okay.
30,
Then
30,
hmm,
4,
hmm.
then true. I guess.
Then
No, this will true would go to the other side, I suppose. It will be from one. It will go to the reverse side.
False, I guess.
we need to
Should
get
be
the less
false.
than, sir. We need to get the less than. So we will keep it true only.
35.
Less than means true. Greater than means false. Right?
You will need to get less than 35.
Yeah,
So it will be up to
less than 35.
34.
Less than 35, it is fine. So we have passed here 34. It will give me the probability of 0 to 34. Cumulative probability. Fine?
Yes, ma'am.
So that way, I can come here. Anything
T
else?
will,
Sorry?
T will be written, madam. Besides 4, T will be written as true.
No, it's automatically
It
true.
is automatically, it's by default true, ma'am.
Okay, okay.
Fine?
तो प्रोबेबिलिटी ने पूरे दिमाग की एक्सरसाइज करवा दिया इसको.
Okay, one more question I'm putting in a chat. Question is available in a chat. I think you people have read and you are trying it. Done?
It's 0.77.
I have to check the answer, ma'am. I haven't checked. And can you tell me the syntax you have written?
Yes, ma'am. It's P norm by
Yes.
50,000, 20,000, 40,000.
Mhm.
I get an answer as 0.3085.
And for what is the syntax you used?
I use phenome 40,000, 50,000, 20,000, T.
Okay.
No, whether it's correct or not.
I think very close. You are very correct. But
Okay, fine. Let me just rectify. Sorry, it should be 13. I don't know how to now. Shall I go what 39999 sort of thing?
Yes. Yes.
Okay. Yeah, got it. It should be one less, right? It's 0.3085. Yeah.
The very small change will be occur. This because the difference is only of 1. So the difference of the probability will be very smaller.
Yeah.
Right? So this way we can use these distributions to get the probabilities, right? I think series of probabilities we have just generated for the binomial distribution, and I told you similarly using the P norm. Suppose you want to generate certain random numbers, right? Talking about R norm. I am generating, suppose, 20 numbers of sample size 100. Just a minute. And sorry, 20 random numbers I want to generate with mean, suppose 10, and standard deviation, suppose 1.2. So these are those random numbers or normal. These are the numbers which will follow the normal distribution once I'll plot them on a graph, right? So the same way now you can use the way we did for the binom function we have used here to generate the histogram. I think where it was like this. So the same way you can go for this particular also, and that way it will show you the distribution of those random numbers, right? Fine, everyone?
Yes, ma'am.
So today I'll ask you for apology because I need to leave little early. I have one FDP I have joined. I am learning some more other software. So today I need to wind up a session right now. I hope it is fine.
It's okay, ma'am. Kindly go ahead and attend your FDP.
Thank you so much. It is from IIM also. So I'm
Okay.
learning some new software from there. Right. So I think for the day I'll keep it till here. Tomorrow I'll try to take so many things for you, and I'll put all the things on a chat that we people can copy it and practice by your own. Right.
Okay.
Okay, ma'am.
Fine. So extremely sorry for today. 10-15 minutes before I'm winding up the session today.
Okay.
No worries, ma'am.
Thank you so
Okay,
much
ma'am. Thank you,
for
ma'am.
understanding. Thank you so much. So I hope I can close the meeting, right?
Yeah, you won't go for a photo click today, right?
Yeah,
You're in a hurry.
definitely. Sorry, I
You're in a
forgot.
hurry.
Sorry, I
No,
forgot.
every day is not required. Same participant, ma'am.
Yeah, we
Same
can have it
participant,
tomorrow,
every day is
ma'am.
good.
Yeah,
No
you
problem.
go
Please
ahead
switch
and
on your
you
camera.
go ahead and
I'll take.
Sorry,
I'll
ma'am,
take.
you are
Suggestion. I'll take. Geeta
No,
ma'am,
no,
I'll
you.
take today.
you are in hurry, ma'am. You please
No,
go.
I'm not in a hurry. No, I'm not in a hurry. You can please switch on your cameras. I'll capture the pics. Geeta ma'am, are you switching on your camera? Just a minute. Due to the sweating, I think there is some problem. Again, I'm capturing.
You should visit North India. It's still cold today.
Oh, but sir, I am having so much sweating on my hand. I don't know why. What is the
Yeah.
problem?
I'm here in Amritsar. It's very cold. Still cold in mid-March also.
Oh my God. And you can, I don't know, you can see or not. There is so much
Okay.
sweat on my palms. If you
Okay.
can
Okay.
see. Okay. So thank you so much everyone for the day and extremely sorry for the day. We will meet tomorrow and start the new thing, right? Thank you so much.
Sure, ma'am. Thank you, sir.
Everyone. Thank you. Good night.
Yeah,
Take care.
thank you. Good night.
Thank you. Yogra sir, are you there? Sir, I'm leaving the meeting, right? Thank you.